Welcome to The Explainer. Everywhere you look right now, from the boardroom to the coffee shop, AI is completely dominating the conversation. But honestly, even for those of us following the tech closely, the absolute avalanche of buzzwords, generative AI, machine learning, foundation models, it can kind of feel like alphabet soup. So today, we're unpacking this hierarchy. We're going to break down how these incredible systems actually function, especially the mechanics behind generative AI models, and give you a crystal clear mental model for how all these pieces fit together. But first, a quick reality check for you. If someone asked you to strictly define the difference between AI, machine learning, and generative AI, where exactly do you draw the lines? People use these terms interchangeably all the time, but understanding their distinct differences is absolutely crucial for navigating today's tech landscape. Okay, let's dive into this. Here's our roadmap for peeling back the layers. First, the artificial intelligence umbrella. Second, pattern recognition through machine learning. Third, deep learning neural networks. Fourth, how generative AI actually works. Fifth, LLMs, RAG, and agents. And finally, the AI adoption explosion. Let's start right at the top with Section 1, the artificial intelligence umbrella. Now, what's really interesting about this is that you should think of artificial intelligence not as a single tool, but as a giant umbrella. It represents the broad goal of simulating human intelligence with a computer. We're essentially trying to build broad systems that can think, reason, and act intelligently. Because when you think about it, intelligence is just the ability to learn, infer, and reason. Everything else we're going to talk about today, machine learning, generative AI, your favorite chatbots, they all live under this massive overarching umbrella. And while it definitely feels like AI just suddenly popped out of nowhere a few years ago, it really isn't brand new. Surprisingly, AI research actually started all the way back in the 1950s. Back then, it was highly premature, mostly academic research using early programming languages like Lisp and Prolog. Fast forward a bit to the 1980s, and we saw expert systems reach critical mass and become way more popularized. But it really wasn't until the 2010s that the foundational layers beneath that broad umbrella, specifically machine learning and deep learning, truly began to mature and take off. Which brings us one layer deeper in Section 2, pattern recognition and machine learning. Machine learning was just a massive turning point. As the name implies, the machine is actually learning. The paradigm shift here is profound. See, before this, if we wanted a computer to do something, we had to explicitly program every single rule line by line. With machine learning, we don't have to do that. Instead, we feed the system large amounts of training data, and the machine observes things and learns the patterns entirely on its own. The more training data you give it, the more confident and accurate the algorithm becomes. It's a real game changer. So, what does this actually look like in practice? Well, because machine learning is so incredible at finding and recognizing patterns, it's exceptionally good at two things: predicting what comes next based on past data and spotting outliers. Think about cybersecurity for a second. Machine learning systems can monitor a network, learn exactly what normal user behavior looks like, and immediately spot a broken sequence, an outlier, that might indicate a hacker is trying to breach the system. It also powers the spam detection in your email and the predictive analytics companies rely on every single day. It solves massive data processing bottlenecks just by finding the pattern in the noise. Let's step even further down the hierarchy in Section 3, deep learning neural networks. If machine learning is a subset of AI, then deep learning is a subset of machine learning. While standard machine learning looks for patterns to make predictions, deep learning takes it to a whole new level, using neural networks that are meant to literally mimic the human brain. And because it utilizes multiple complex layers, it introduces a fascinating quirk: the black box effect. Just like the human brain, it can be pretty unpredictable. Sometimes you put certain things in and you don't always get the exact same thing out. Because there are so many deep layers, it can be incredibly hard to fully decompose the process and figure out exactly why the network gave you a specific result. Zooming into the modern era, we have Section 4, how generative AI works. So, the crucial point is that to really grasp the mechanics of generative AI models, we absolutely have to talk about foundation models. Your basic autocomplete just guesses your next word, right? But foundation models act on a massive scale. They use complex probabilities and statistical patterns learned from vast datasets. They don't just guess a single word. They evaluate the mathematical likelihood of what should logically come next based on the immense context they've ingested. By predicting sequentially at such a massive scale, whether it's predicting the next sentence, a paragraph, or an entire document, they generate entirely new, coherent content. It's basically autocomplete on steroids. Now, there's a really common myth out there that generative AI isn't really generating anything new. that it's just mindlessly regurgitating existing information. I absolutely love this music analogy from our source to bust that myth. Think about music. Every single musical note has already been invented. In a sense, every new song is just a recombination, a permutation of notes that already exist. But we never say new music doesn't exist, right? People are constantly composing new songs. Generative AI is very similar. It's taking the vast, fundamental building blocks it learned during training and creating genuinely new content. It's how we get amazing new digital images, entirely original written code, even audio deepfakes that can recreate a person's voice saying things they've never actually said. Shifting to the bleeding edge of the AI hierarchy, we have Section 5, LLMs, RAG, and agents. And this brilliantly illustrates the specific modern concepts being built on this generative foundation. Let's quickly demystify the terms dominating the space right now. First up, LLMs, or large language models. These are a specific type of generative AI purely focused on understanding and generating language. Think your GPT-4s, Claude 3s, or Gemini. Next, we have RAG, which stands for Retrieval Augmented Generation. This is where we combine the creative power of generative AI with a database of external, up-to-date knowledge to give much more accurate answers. It's the engine behind highly accurate enterprise chatbots or document Q&A systems. And finally, agentic AI, or AI agents. These are autonomous AI systems that don't just generate text, they actually reason, plan, use digital tools, and take autonomous actions toward a goal. As you can see, they all build upon each other step by step. And finally, our last section, the AI adoption explosion. For literally decades, AI adoption was, well, a pretty slow crawl. For a very long time, it was perceived as this fascinating research project that was just perpetually 5 to 10 years away. Sure, machine learning and deep learning started creating some uptake in the background of our everyday apps, but when foundation models and generative AI hit the public consciousness, the adoption curve didn't just accelerate, it went straight to the moon. The sheer ability to generate new text, summarize complex documents, and create images completely captured the public's imagination. It caused an absolute explosion in everyday adoption. We went from the research lab to literally everyone's pocket seemingly overnight. So we've journeyed all the way from the broad, early concepts of artificial intelligence, down through the pattern finding of machine learning, the deep neural networks of deep learning, and into the world-changing mechanics of generative AI and foundation models. You now have a clear, structured mental model of this entire hierarchy. The AI landscape isn't just a bunch of random buzzwords anymore. So my final question to you is this. Now that you actually understand the mechanics beneath the magic, especially how generative models and agents can synthesize and act on information, how will you adapt your own skills? Which level of this hierarchy are you going to leverage to build solutions in your own work? Think about it and start building. Thanks for joining me on this explainer, and keep learning.